the concept starts with what is called as the information processing system, right? So the messages which we want to communicate from one location to other location by means of any communication technique, right, will be basically considered as what is called as information processing system. So they are also called as simply information systems. Okay. Now this basically consists of uh, various components. We try to represent the component in those components in the form of a block diagram. Okay, so the first component that we will be using here is called as the information source. Okay, so information source basically it can be we may think it can be analog or it can be discrete or digital, right? For example, if you want to say that my information source is analog, example could be a microphone, right, which is basically actuated by speech. Okay, when I talk, right, a microphone records in it, right, the analog waveform corresponding to that, right? It can also be the camera, right, like an older camera that actually scans the given scene in a very continuous fashion. All right, at the same time, if you want to say that the information source is digital or discrete, right, this could be uh, the characters that we are typing on by using a keyboard. If you type the letters, they are going to be discrete in nature, right? So each character will be discretely captured, right? A keyboard, right? When you enter something from the keyboard, it is discrete, right? So like that. So again, the message stream coming out of a computer will be in the discrete format. So you see that information source can be continuous or discrete. So that is what is the information source. All right. So information source basically generates the information, right, in analog or the discrete format. And analog you give an example, discrete you give another example. That's all. That's what you need to write about the information source. Okay, we already know about this. Let's proceed further. So the second part will be called as an encoder. Right. So this is basically on the source, is whatever the source message we have, we are trying to encode that. Okay. So this encoder is basically referred to as, right, source encoder, right? Source information is getting encoded over here. Okay, so that's what is the source encoder. But normally what happens, this encode itself will have two parts. Okay, one is the source encoder, which we have just now talked, we were talking about the information, information coming into the encoder, right, will be converted into the appropriate format by the source encoder. That is the information source itself getting encoded. Okay, so that's what is the source encoder. Whereas sometimes what happens, I may have to uh, do the encoding once again. So second time encoding might be required. That is because the the information, whatever is encoded by the source encoder, right, that is not enough. Okay, that may have to be converted into a different format for the purpose of the transmitting through the channel. So you need to talk about two things when this particular point comes, whenever you are trying to explain the encoder, that I'll just write here. Okay, dotted lines. This is not a part of the diagram, but this is just for your reference. This encoder will be of basically you can have two parts here. Okay, so I'll just write both the parts here. So one of the part of this encoder is called as the source encoder. Second part will be called as the channel, right? This is what, right, we need to explain. I just wrote it below so that you can simply remember what we are doing. Encoder meaning we understand, right? You are converting one format of the data into another format. You are coding it. Maybe, right, it is analog. Whatever comes here is analog. You encode that into zeros and ones. Okay, so that's what is a one type of encoder. Okay, right. So this is what is going to happen inside the encoder part. Then, right, encoder's output will be, right, uh, the channel encoded data, so that you can use a transmitter to send this data. I need another circuit to send this data onto the channel, right? So that is what we call as the transmitter. So various types of transmitters we have studied, right, in communications, right? So use any one of them so that you can transmit the given data onto the next part that is coming. That will be the channel. So transmitter can also be, if you refer some other books, right? Some of the books may also call this as a modulator. That's one and same. Okay. You will have modulator inside our transmitter, correct? So it's fine. Then this will be connected to another part and we call that part as the channel. So if I have to define the channel, right, this is that physical medium which carries the information sent in any format by the transmitter, right? It will send that to the receiver. It will carry the message. Okay, so that's what we need to define. So this is that. Okay, so this is the channel is the one which carries that. But the fundamental property of the channel is that it will most of the time it will try to corrupt your information which you transmit. So by means of what is called as the noise, it will add noise into this. So we have to show that. So I just have to talk about the channel. Channel is the physical medium which carries the information from the source to the destination or transmitter to the receiver. During that, normally there is it will add what is called as a noise. Okay, so that's the thing I need to explain. On the other side, so channel will deliver the message to the other side. So other side will be, right, it's opposite of what we are doing here. So that will be uh, a receiver. Okay, so we will be having a receiver. So let's, this can also be represented as a demodulator in some of the books. So whatever channel delivers will be picked up by this receiver. So it's opposite of the transmitter. Whatever transmitter has done, maybe there is a modulation like ASK, FSK, PSK, or if it is continuous AM, FM, whatever. Right. So that needs to be reversed by this receiver. Inside that, we'll be having a demodulator. Now, demodulator's output will be the encoded wave, right? I need to decode that just to understand what exactly has been said, right? So for that reason, we are going to use the decoder. So again, the decoder will have two parts in it, right? It has to decode two types, right? Two various types of decoding needs to be performed because of the fact that we had done two types of encoding on one side. correct, on the other side. So same thing I'll will do on this side. So the decoding is a two-step process. So first thing is I did the channel encoding at a later stage. So I'll do the channel decoding first here. Okay. So channel decoder, then the source decoder. Once the source decoding happens, right, now it is very clear that I'm going to get back my message signal, right? So the information will be delivered on the other side. Information. So overall, we just have to explain each and every block in one or two sentences to finish the whole concept. Okay, of what is called as the information transmission receiving system, or in general, the information processing system, or simply information system. Okay, so that's the first normal question that we see, or we people expect us to explain when it comes to the information theory and coding. Okay, now, so many times we use the word information. So the idea is that how do you measure the information? Because, right, when I said that, okay, I'm processing an information, I may send a message which may not contain any information. Okay, or I may send a message which contains a lot of information. Correct? Every message that we send, it is not necessary that that contains the information. Correct? So because of which now I have to bring up some idea so that you can measure, right? So let's go for the information measurement. How to measure the information, we'll see that. Okay, now, so most of the time we are going to send the message in the form of in the binary form. Okay, so binary format is uh, the most common one to be used. So what we can do, right, if we have a message, so how do you measure the message is the first point, right? And then we will see, right, how do we identify the message. Okay, so first information measurement is our topic. So let us consider that there is a communication system. Okay, that communication system transmits various messages. Okay, like maybe if my system is a binary system, I may send the messages in the format such as zeros and ones. Is that okay? Right? So my system is binary, so I will send only two messages, zeros and ones. Okay, but now let's see. Okay, let me try to write one sentence over here. Let the communication communication system transmits the messages. I'll give a message some name. Okay, so maybe M1 comma M2 comma M3 dot dot dot, like that I send many messages. So now you see, I want to define the message with a probability. Okay, so the with the probabilities. So P1 is the probability of message M1 being generated or being transmitted. Okay, P2 is the probability that M2 is being transmitted. Okay, and P3 and so on. Okay, this is what is the fundamental assumption. Now I will give you an idea that why the probabilities are required once we finish this definition. Okay, now uh, if that is the case, then the information contained in any of the message I can try to measure using the probability. Okay, so I'll write the statement first, then the information content of any message. Let us denote that message as say mk, m1, m2, m3 dot dot dot. It's mk, any kth message, right? Information content of any message mk, right, with probability. So what should be the probability now? Pk. Okay, because mk is the kth message, pk is the kth probability, right, is given by ik, information of the kth message or kth symbol. How do you measure? This is log of log to the base 2 of 1 divided by pk. Now I'll directly come to the point. Why do I use this log? Okay, sorry, why do I use the probability? Okay, why do I use the probability? First point. And the second point is, why do I use a log? Right, two things are needed. Okay, so let's consider a scenario first. Let's say that let's say it is a rainy day, it's a rainy season, and somebody calls you and tells, they're going to tell you that today it's going to rain. Okay, right. So what is the do you get any information from that? You say yes, you get information. But no, no, I'm saying that it is a rainy season, it's going to rain. Okay, it's a rainy season, so you already know that it's going to rain. So somebody tells you that, right? What you know, what you already know, right? What you already know does not give you any information, because it's a known fact that it is a rainy day and it's going to rain, right? So even if somebody tells you that it's going to rain today, right, you will say yes, of course, right? Fine. Now let's change the scenario, right? it's non it's not a rainy season at all. Okay, it's not a rainy season. So somebody calls you and they're going to tell you that it's going to rain today, right? Is that an information? Will it contain more information than the previous case, or it's going to contain the same amount of information like earlier? It will be I understand that, okay, there is actually some more information, right, compared to my previous case, because today is not a rainy season, right? This day is not in a rainy season. So the occurrence of rain in a non-rainy season is a very rare event, correct? Rare event means, what is the probability? Is it high or low? No, 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 just understand the question again. It's a rare event. Today there is no chance of rain. No chance of rain means probability of rain is lower, correct? Right. So I understand that whenever the probability is less, it is going to generate more information. Okay. Whenever the probability is high, like a rainy day, and somebody tells you it's going to rain, yes, I know that probability of rain is very high, information content is less. So the relationship is like this. The relationship I'm going to write now. So if the okay, I'll write it in this way. Let me write. So the information of any message is actually inversely proportional to the probability. I understood this, correct? Right? So probability was less for rain, it actually yielded highest information. So probability less, information is more. So I understand that I need to have inverse relationship. So that inverse relationship I can see here, ik is equal to information is 1 by probability. Okay, That's one thing. And so we try to put it inside the log because we don't want to get a bigger number, right? We want to compress the numbers. Log will compress your numbers, right? So if you remember log to the base 10, right? Uh, 0 will be, if I want to put any numbers between say 1 and 2, right? If you use log 10, I can represent 10 and 100 between just 1 and 2, correct? 10 to the power 1 and 10 to the power 2. So this powers, if you try to represent, the numbers can be compressed. That's the only reason why we are using the log here. Is it okay? Right. So whatever probability, because if you get a probability value which is 0.000002, if you simply take 1 by pk, it is very big number. I don't want to go for such a bigger number represented. Simply take a log of that. Now, what base you take, right? Depending on that, we have various units of measurement. Okay. So now I have written it as log to the base 2. It is just one case where my transmission and the reception uses binary data transmission, right? Anyway, so this is the most general format of writing. Now I will go for various units. Okay, what are the various units possible, right? So let me try to write the units of information. There has to be some unit, just because whenever we measure a mass we say kg, or you can even go for other, right, measurements like grams only, or whatever, like velocity has meter per second, right, etc. We need some units, so that reason we use this. Now if at all I use the information I, right, as log to the base 2 of 1 by probability, then this has a unit called as bits. So information comes in bits, right? Maybe 1 bit of information, 2 bits of information, like that. Okay, because it is base 2. Okay, but let's say I'm not using base 2. Instead of that, I use log to the base 10 of 1 by probability. This is also valid, but the measurement is not going to happen in case of the bits. It's going to happen in terms of the decits, because it is base 10. Okay, so decits, yeah, decits are also called as the heartbeat. All right, so the third option is I is equal to log to the base e of 1 by p. You take log to the base e, right? If you remember, this will be called as nats. Okay, Napier's or nats. This will be represented in, I think, NEPERs. Napier's or its nats. Whichever we want, we can use it. Okay, right. We can convert one to the other by using the properties of logarithms, right? We can simply use that to do the conversion between them. Is it okay? All right. Now, so fine. Quickly, let's go to a problem. We'll solve a problem, then we proceed. Okay, so this is the question number 1. This is a problem number 1, right? Source sends 5 messages with the probabilities. So that is P1 equals to 1 by 2. P2 equals to 1 by 4. P3 equals to 1 by 8. P4 equals to 1 by 16. And the P5 is also equal to 1 by 16. Right? So find the information information content of each message. Okay, so they can ask you to find in decids, find in Napiers, find in bits, depending on the question. If nothing is asked, you are free to choose any message, any base that you want to calculate. Okay, so normally we go for the bits only. So I1 is equal to, this is log to the base 2 of 1 divided by the P1, correct? So this has to be log to the base 2 of 1 over 1 by 2. So that is simply equal to log to the base 2 of 2. How much? That will be equal to 1. So unit bit, 1 bits of information. Are you fine with this? So like that, we need to calculate the others. I2 is equal to, this is log to the base 2, 1 by P2. I can see that the P2 is 1 by 4. So log to the base 2 of 1 over 1 by 4 is 4. So log to the base 4 of 2 is 2. 2 bits of information. Like that, the I3 will be equal to, this is log to the base 2 of 1 by P3 as per our equation. So this will be equal to log to the base 2 of 8. That should be 3 bits. Now it's very clear that whatever we had studied is right being applied here. Probability is lesser, like P2, P3, P4 have lesser probabilities than P1. So we can see that the same thing is happening with this. Information content is being shown, which are higher compared to the message one. So I4 and I5 are going to have the same answer. So that is log to the base 2 of 1 divided by P4 equal to P5. Both are same. Okay, so that will be log to the base 2 of 16. So that will be 4 bits of information. Okay, so this, the information content of your message signal is also referred to as the self information. Okay, so I'll just bring the word because sometimes they say that calculate the self information, right? Units of information, or this is called as the self information. Is it okay? Right. Okay, so the next question is find the information contents of the two message symbols of probabilities. P1 is equal to 1 by 4 and P2 is equal to 3 by 4. 1 by 4 and 3 by 4 are the probabilities in, right, in, represent that in bits, represent that in decids, and also represent that in nats. Okay, so this is the question. So let's quickly try to do a table over here, so that will help you in getting the answer easily. So this is the probability, so I can write the pk. So if you want to measure the information in in bits, right, so this is I in bits, this has to be right, log to the base 2 of 1 by pk, right? I'll do that. I'll write it below this. Then if I want to calculate the I information in decids, what is the equation? This is log to the base 10 of 1 by pk. So similarly, if at all I want to write the I in maths, so this has to be log to the base e of 1 by pk. Okay, so this is what we are trying to calculate now. So two values are given. One is 1 by 4 and one is 3 by 4. So put the pk values into the equations and fill the table. Let me know once you get the answers. So this is 2 bits. This is 0.602. Okay. Okay. So I in nats is 1.38. That's right. Correct. 0.28 for nats. 0.12. So we have a 0.41. So we can see that the probability is more, will have lesser information content, right? Okay. So one point is very clear now. So how do we measure the information? What will be the representation, right? What are the various units used? We have understood so far. Okay. Now, when I have a lot of messages coming in, right? Normally, we don't measure that by looking at the message content of each and every symbols or each and every messages. What you do, normally you see, I'll give an example. Let's say I am traveling for maybe I'm traveling 1000 kilometers of distance, right? I want to uh, measure the okay mileage of my car maybe. And what you do normally, you don't say that okay, between first 100 kilometers I mileage was this, then next 100 like this. You don't do that, right? What you do, you take an average, right? So average is the one which speaks about the overall performance. Like that, we are going to use what is called as the average information content of the complete message. Message can be very long, containing thousands of symbols. So far we consider just one or two symbols, four, five, maybe 10 symbols, or just like that, correct? But now you see, we are trying to look at the big picture over here. If my message is very long, right, containing thousands of symbols, calculating the information content of each symbol and representing that in the form of a table, right, will not help us. That will not give you any picture about the data or the information, correct, or the message. So what you do, you go for the big picture over here of your complete information by looking at what is called as the average information content. Okay, average information content of a message is also called as, this is the important word, which is called as the entropy. Right? So long message will have many number of sequence. We are trying to calculate what is the average information content of this message, which is the average of the message present in each of your symbol. So anyway, average we understood. We take the sum of the information of every message and divide by the number of right symbols. That's what we do. Let's see how That concept can be applied over here, right, to calculate the average information content. Okay, right. Now, so for this, we have to make an assumption. Uh, we'll start it's actually a small derivation, right? We'll start like this. Let the information source emits capital N different symbols. It's going to send M different symbols. Okay, what are the symbols? S1, S2, S3, dot 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 up to SA. Okay, now you see there has to be one assumption made, that is the the message symbol that is being sent is independent of other symbols, means they have to be statistically independent. The word statistically independent means that occurrence of S1 has nothing to do with S2, S3, S4 up to Sn, because sometimes you may have a case wherein the symbols are not statistically independent. Statistically dependent case is that after S2, S1 will occur. Once the S2 happens, immediately next S1 will happen. If that is the case, it is statistically dependent. But now what we are saying, it's statistically independent. Okay, so I just have to mention that because it's completely the occurrence of a symbol is right. It's independent of the other symbol, so we call it as a statistically independent fashion. Okay, so M different symbols S1, S2 up to Sn in statistically independent fashion to form a sequence. Okay, now I know that I am trying to measure the information content. So whenever my intention is to find the information content, I need the probabilities. Okay, right. So let, this is my next point. So let, uh, I'll write the probabilities P1, P2, dot, 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 up to Pn be the probabilities be the probabilities of of occurrence of those M symbols. Okay, now we are expecting a very long message. Okay, let us assume that the length of, now you see you have say M different symbols, but all the M symbols might not be used in your actual communication. You may have used say 10 out of it. So you see I need a different number capital N saying that this is the length of my message, but this N is very large. All right, so I'm expecting a long message. So let the length of the long message be capital N symbols. So N is the length of the message you receive. It may contain, so if like P1, P2, P3, etc. up to Pn, let's say they are the English alphabets, A, B, C, D up to Z. Maybe all in capitals, let's assume. So you see P1 is A, P1 is a probability of A, P2 is a probability of B. So PZ is the probability of Z, like that. So you have 26 symbols. Out of the 26, you might not use all of them. If I'm sending a message saying that hello, right? You see that only few of them are used to in my message. right? So the length of n is equal, the n equal to length of your hello, that is 1 2 3 4 5. Okay, so n is 5, m is equal to 26, but right now it is not that case. N is very large, let us assume. Okay, because we are interested in finding the average rather than the individual message content. Okay, right. So in such case, right, uh, out of n symbols, how many first symbols will occur, right? So that's what is my point. You see, S1 is the probability. Okay, S1 is my, sorry, S1 is a message signal, P1 is a probability. Okay, that is something like A, and the probability of A could be, say, B, say it is 1 by 2, possibly. Okay, if that is the case, out of 10 symbols you receive, you see capital N is equal to 10, right? N equal to 10. How many A's you are going to receive? Number of A's should be equal to, it is the length into the probability of A, correct? So it is 10 into, if I say half, I am expecting 5 A's. You see what I multiplied? I multiplied the length into the probability of that particular symbol. This is what gives me an idea that how many symbols are occurring for each given different symbol, right? How many number of times each symbol repeats. Okay, so I'm going to use that concept over here. Then the symbol S1 occurs, right? How many times? P1 into n times, correct? Are you okay? Just now I did. So A occurs, probability of A, which is half, into this length. If length is 10, so half into 10, it's 5 times. Now it is S1 occurs these many times. Similarly, I can say S2 occurs. How many times? It is the probability of S2, that is P2 into n times, and so on, correct? This repeats. For all the symbols, this is going to happen. Is it okay? Right. So many times it will repeat. So in general, I'll write, in general, any symbol Si occurs how many times? It is Pi into n times. Are you okay? Fine. Okay, now what we do? Now we'll go one step ahead, right? And the information content of any ith symbol, right? Ith symbol just depends on its probability, correct? It's Pi. Simply Pi will give you the information content of ith symbol. For example, information content of A, if I want to calculate, how do I do that? Simply log of 1 by probability of A. That's all, right? That I'm going to use now. So also the okay, I'll write information content. Also the information content of ith symbol, right, is, right, ith symbol is equal to, what is that? It's simply log, let's use the bits only, log to the base 2 1 divided by Pi. That's fine for us, correct? Now you see the ith symbol repeats Pi into n times, correct? So Pi into n times, this is the information. So each repetition is going to add up the information content by this much amount, correct? If it is repeating 1 times, it is going to give you Pi into log to the base 2 of 1 by Pi. Now each symbol is repeated how many times? Pi into n times. Are you okay with that? Right. So now I am calculating the total information. The total information, the total information content of the message of the message is, let me write it as I total. How do you calculate that? It is every message, how many times each message repeats into its information content. So I can write it as summation, say I varying from 1 to n, because there are that's the length of my received message is capital N. For each of the received symbol, you do this. That is n times pi log to the base 2 1 divided by pi. Okay, this is the total message, sorry, total information. Is it okay? Okay, sorry, there is a small mistake. It's not n because you have to calculate for every m symbols. Okay, for all the m symbols you have to repeat. So this is not n, this will be m. Is it okay? For each and every symbol that is present in your dictionary, you should do this, isn't it? So starting from A, B, C, D up to Z, check that whichever appears, how many times, do the calculation. Okay, so it's not n, it's m, right? Upper limit is this. Now you see, I want to calculate the average. Average is what? The total divided by the number of symbols. Therefore, average information, it's per symbol, right? So average information per symbol, we denote that it's actually the entropy. I'll write the word entropy, or average message per symbol, denoted as capital H, is a notation. This is nothing but the I total which you have calculated divided by the number, right? So what I do, summation I is equal to 1 to m n into pi log to the base 2 1 by pi whole divided by, I'm going to divide that by n. So this n and n cancels out. So you can see that the final equation for h becomes equal to summation I is equal to 1 to m, right? Simply it is pi log to the base 2 1 by pi. So log gives you the bits. Since you divide this by the symbols, right, the total number of symbols, you see that it is bits per symbol. Okay, that is the unit you use. All right, so the H is also called as, it's simply entropy, or some of the authors will call it as the source entropy. So when question says find the source entropy of the system, you are supposed to do the calculation of H only. Okay, don't get confused. Simply calculate H and that's the answer. Okay, I think that's the derivation of the information content, or average information content, or the source entropy.